a vendor in the domain of static source code analysis, and I'm located in our R&D center in Taipei, Taiwan. Coming from a vendor in this domain, obviously, frameworks and how they mess up static source code analysis scans or static security scans of your source code, of your applications, is something that we are very familiar with. And one of the motivations for this talk was that we run into several cases where there are misunderstandings about the technology, and specifically about the technology limitations, and how they conflict or how they are hit by frameworks or the way that frameworks work in your web applications. So this talk is supposed to give you a quick overview of the technology, what limitations there are, how frameworks come in, and then some ideas about a tool and vendor agnostic approach of how these limitations could be overcome or how these issues can be addressed. So just a quick motivation or some introduction and points for the introduction. Frameworks are omnipresent when you're dealing with web applications. Any mildly interesting web application nowadays is not just using the standard language or the standard platform that it's written in, but is using some kind of framework that is used to make the life easier for developers. So if you're dealing with any interestingly sized applications, you also have to deal with frameworks. So if you're performing security analysis on your web application, chances are you need to take frameworks into consideration there. Now, the issue with frameworks is that they extend the standard application model. So let's take Java as an example. With the Java EE platform, you have your web XML, which defines your servlets, you have your servlet filters, and this is kind of what you're aware of. You know, there are JSP pages, there are servlets, this is kind of what you're dealing with. When frameworks come in, so Spring, Struts, whatever your poison is, you're now in a situation where, in addition to those standard concepts, there are additional actions, interceptors, other framework-specific filters that hook in somewhere in the flow of the server rendering your web page or dealing with the application in general. And I'm not even mentioning EJBs or anything that's happening in other tiers here. So from a scanning perspective, or somebody that is looking into the source code, and that also affects, obviously, manual inspection, you need to be aware of what this additional model looks like to not oversee something or to take everything into consideration that actually might have an effect on your application as it is being executed. And this is where static code analysis kind of hits its limits, because if you want to look at the application, look at the complete model, you need to know about the model. So just looking at the source code, it doesn't really tell me that, well, this class is an action and this action is actually being invoked if whatever comes in back from the user. That's something that you need to know. The other thing is that the way that the frameworks deal with these issues or make it easy for the developers, they're using certain coding technologies that kind of hit exactly at the limits where a static analysis kind of ends, just from the way that the technology is defined. Also, a little warning up ahead, there are going to be some code examples here. I'm going to try to keep them simple, but if you don't know Java at all, then there might be one or two slides where you might have some questions afterwards. This kind of brings up two questions in general. One is, can frameworks be addressed by static source code analysis at all? Or does, as soon as you bring a framework in, this renders your tool or whatever technology you're using for static analysis useless? Obviously, I hope to kind of show during the presentation that this is a yes, so you can address it. The other thing is, can this be done in an open and extensible way? Because obviously, if you're looking at a smaller problem space, you're only looking at certain frameworks, this doesn't give you a lot. Because chances are you're not only using one framework, you're using a number, or if you're from a vendor perspective, your customer is going to use a wider range of frameworks that you have to deal with. And in the worst case scenario, you have your homegrown framework, something that has been developed internally and that is used by, in a number of applications that you don't even know, and that probably even part of the developers don't really understand because it was written 3 years ago, there's no documentation, and it just works somehow. So quick introduction, just bring everybody on the same page. Static source code analysis. It's a compile time analysis, and it works either on code or binaries, depending on what tool you're using, depending on what technology you're using, or also what language you're using. Maybe you don't even have binaries for scripted languages like PHP or ASP Classic. It is mostly data flow oriented, so it doesn't pretend to be the all magic potion that you can just spill out and find all the vulnerabilities. This mostly is oriented on stuff like cross-site scripting, SQL injection, which is already a pretty big domain of vulnerabilities. So if you get to handle those pretty early in your development cycle, that's pretty nice. This is kind of where it fits in on the scale of your standard design implementation QA production scale here. And this is the advantage and disadvantage at the same time. The advantage, obviously, is that it's one of these technologies that you can use rather early in the cycle, as opposed to, for example, penetration testing, where you need to have a fully running application that you penetrate against. Static source code analysis can run on a part of the code, so it can be run early in the implementation phase, which helps you to fix bugs early, but also obviously introduces some issues with what if not the complete code is there, or what if something is used that will be present later in the execution environment, but is not available right now. It is able to provide traces and, well, in most cases, and points to the line of code where the vulnerability actually happens. So this is the advantage of dealing with source code. You can actually pinpoint directly to the developer what's going on, or as a security consultant, it really points you to the area of code where you might want to look in a little bit more closely. And it's potentially integrated in the development process, which again is the advantage of dealing with stuff early, but has the disadvantage of having to deal with potentially incomplete information. So this immediately brings up the technology limits. The first thing is source code static analysis, by definition, kind of is run at compile time. So there's no runtime information available. Whenever you're running a piece of code that is depending on anything coming in from the user, you have to guess. You don't know what's going on, so that obviously introduces a lot of variables that you have to deal with in the process. Any runtime types are unknown. So as soon as you're dealing with reflection, which I'm going to talk about in a second here, or where anything is instantiated on the fly, or you're getting it from an external service, there's a big question mark. So this is something that also needs to be taken into consideration. You need to make an estimate whenever that happens. And this can lead to the program flow being unclear. I mentioned before, static analysis is mostly focused on data flow, so you need to kind of know where the data is flowing. If the flow is not intangible, or you kind of can't figure out what's going on, you're losing your trace here. So you're kind of blocked from the further analysis. The execution environment is not accessible. So if you're accessing a database, if you're accessing some other services, all of them don't exist at scan time, so you cannot get further insight into what might be accessed here, or where the information is actually being written to, because it's just some opaque interface that you're seeing. And obviously, the code might be incomplete. So what happens if an interface is used, but you don't find any implementation of that interface because it's mocked up, or it's going to be provided later on by some injection or some other ways of gluing the application together with the execution environment. And then this is the point I pointed out in the beginning, the application model must be known. So if you're looking at the source code, you need to be aware of where does the source code actually fit into the whole process, from the user sending a request to your server and you're sending something back to the user. If there are any parts that you don't know about, there's a big chance you're actually missing out on a large portion of the logic or the functionality that's actually going on. So how about frameworks? How do they fit in? I mentioned before, they're used very often, and they're here to help you. So they're, that's also one of the reasons why they are popular. Nobody wants to start off with the simple, JSP or ASPX page or whatnot, and then write your whole way of parsing the URL, figuring out what to do, figuring out what the database is, So, and I'm just mentioning a couple of here, mostly Java-oriented. If you go into Ruby or Grails or what have you, there's a lot of stuff that actually makes making web pages very easy, but also introduces a lot of magic that happens in the background. So they help you to figure out what action to invoke or what functionality to invoke based on the URL. In a lot of cases, they prepare the data for you. So if you're accessing data from the user, they might nicely wrap it in some active object or some other form of bean in Java that you can access very easily, so you don't have to parse data from the scratch. But again, as you kind of see where this is going, you kind of need to know where the data is coming from. So how is the framework processing it? Is the framework actually processing it in a safe way, or is it just wrapping it in a way and you still need to be careful what's going on? And it separates business logic from views, which is also a good thing, best practices, so something you should do anyway. and it kind of forces you to do that. However, as I said, a lot of magic is going on in the background. So suddenly your action is being invoked by the framework because it decides to do so. So there's some callback going on, which, depending on your view on application development, that actually is also something that's questionable. So you want to be in control, and now you're kind of handing off the complete control to this big blob that is doing everything for you. Obviously, this helps you a lot, but you don't really know, if something goes wrong, was that me or was that something in the background? And the runtime behavior is opaque. So one of the things that often comes up is, well, if you're scanning the source code application, why don't you just scan the framework source code at the same time? So shouldn't they ideally work together? Well, as you'll see in a minute, there's a lot of stuff that's going on in the framework source code that is beyond the limits of what static analysis can understand. So this is where it becomes tricky. So let's take struts as an example. So this is struts 1, actually. I kind of wanted to keep it simple. The big blob that I mentioned in the beginning. So let's start with the user request, and this is just a very simple example for some registration flow or whatever. The user submits the URL, struts takes the URL, parses it, and the first thing it does is it's going to look up in its configuration file what action or what kind of next step this URL responds to. So depending on what it finds, it will figure out, oh, there's this registration action I should invoke. So it's parsing it, invoking it, wrapping the data, giving it in form of a bean to the action. Now your part comes in, the application tries to figure out what's going on and responds appropriately, sends back the response. And based on the response you're sending back, again, Struts is going back to the configuration file and checks, okay, you gave me a no, yes, for a success, fail, whatever, for the response. And depending on this, I'm going to forward this to whatever view you've defined in this case. So there's a lot of stuff going on, and the application kind of is happening down here at the bottom, while all the upper part, specifically this big ominous struts configuration XML file, is in the background going on in struts. So where's the problem? Well, the first problem, if we kind of go through the points that you just saw in the slides, the first step of trying to figure out what action to invoke, that in most cases will probably happen with reflection. So reflection, as a quick introduction, means that the program can modify a structure at runtime. And by the underlining, you immediately realize, well, we are static, so our runtime type is unknown. So if it starts to change its behavior at runtime, that's something that is kind of beyond the scope of what we can figure out by just looking at the source code. To give you a quick example down here, so in case you're familiar with Java, that basically just means I have my action as the name of the action that I want to invoke, and this is probably a class name in this case. And I tell the system, well, load the class, whatever entity that defines this class, based on name, instantiate it, and I'm casting it here to an action, so it all needs to implement an interface, because obviously you cannot do whatever you want. If you want to use struts, you need to confine inside a certain contract with the framework. And then on this action that I just instantiated, go and execute my request, and this will do whatever the application logic is telling it to do. Well, now the issue is, when you're writing this, and this is definitely the issue in the source code of the framework, obviously you don't know what my action is, because otherwise you wouldn't do it this complicated way. You would just say, well, take a new my action and execute it. So this becomes a big question mark, yes, if you're looking at the source code, and that obviously poses a number of questions, like, where do you go from here? Well, there's a chance that I know what the action interface is here, I can figure that out, but now there might be a number of implementation of that. The other case would be, well, I find the action interface, but I don't find any implementations, because they're going to be provided by some fancy OSGI or whatever injection methodology later on. So I either kind of know where I'm going, but I'm not sure, or I'm kind of stuck, and I don't know what's going on here. If this is your implementation hierarchy, things can get a little bit more complicated too, because obviously they're not just a number of implementation, they can be hundreds, they can have nested stuff, some of these might not even be invoked, depending on some runtime behavior. So things are looking kind of awry from this point on. If the flow trace is broken, you're now risking a false negative. So if you don't know where you're going because you don't find any implementation here, obviously you're going to miss something in case execute is actually vulnerable. The other case you're having, if it's unclear, so if you're just trying everything that you're finding, chances are you're going to run into